Morning to all of you. Today we are going to see about earth resistance measurement. Here this is a earth resistance tester. Here we have four knobs actually, E1, P1, P2, E2, and we have one switch actually. It is in the range of 10 ohms to 1000 ohms. The two ranges we have. By varying this knob we can adjust it. Now I have put it to 10 ohms. Okay. By selecting 10 ohms we have to connect the wires in this. Actually we have four knobs here. One is a E1. This E1 is nothing but a current electrode terminal, and P1 is nothing but potential electrode terminal. P2 is nothing but again potential electrode terminal. E2 is the current electrode terminal. We have to short E1 and P1 with the help of wire, and one wire is taken in this point and it is connected to the earth pit. This is the earth pit we are going to connect, and P2 one wire is taken and it is connected to the one of the electrode, and E2 another wire is taken and it is connected to the another electrode. Okay. Here we have to keep the one electrode at a distance of 5 meter from the earth pit. Another electrode is kept at the distance of 10 meter from the earth pit. Okay, we have to keep moving the electrodes, and we have to measure the earth resistance by pressing this test button. By keep pressing this test button, it will show you how much amount of earth resistance is. It will show you. Okay, this is how we are able to measure the earth resistance. This method is working based upon Ohm's law. Ohm's law means R is equal to V by I. Fall of potential method is used. It is widely used in communication systems and power based industries. It is having a lot of applications. We are going to see the demonstration, live demonstration right now. We can see it now. Here if you look at this E1, this is the current electrode terminal, this is a potential electrode terminal, P2 is the potential electrode terminal, E2 is the current electrode terminal. In some of the measure it is mentioned that instead of E1 it is mentioned as C1, P1, P2 and C2. Okay, this is E1 means current electrode, P1 means potential electrode, P2 means potential electrode, E2 means current electrode. Okay, here what we have done is we have shorted E1 and P1 terminal, and it is this yellow wire goes to the earth pit. Okay, we have connected to the earth pit, and then we have to take one more wire from potential electrode, and we have to connect, we have to bury into the soil, and we have to connect it to the P2, and another wire is taken and it is connected to the E2. That is current electrode terminal. Okay, here in the soil we have so many ions actually, sodium, potassium, chloride, magnesium. The the function of electrode is used to convert ionic potential into electrical potential. That is what we are using rod actually. The electrode converts ionic potential into electrical potential, and then the display what we are having is actually the resistance value will be displayed here. By keep pressing this test button, it will show you the earth resistance. Okay, now we can see the live demonstration. We will show you how we have to connect the electrodes. These are all the measurement tools actually. This is the earth resistance tester kit toolbox, and these are all the electrodes, and this is a hammer. This is a measuring tape we are going to use, and this is a circuit diagram we are going to connect actually. E1 and P1, P2, E2. E1 current electrode, P1 is a potential electrode terminal, P2 is a potential electrode terminal, E2 is a current electrode terminal. We have shorted E1 and P1, and we are connected to the earth bit, and one wire is taken and it is connected to the one of the electrode, that is potential electrode, and another electrode, another wire is connected to the E2, and it is connected to the that is a current electrode terminal. Okay, here what we are using is actually the principle of measuring earth resistance is according to Ohm's law. Resistance is earth resistance is measured according to Ohm's law, that is R is equal to voltage divided by current. Okay, this is the equation we are able to follow in this experiment. The method what we are using is actually Paula potential. Potential is falling. If you look at this diagram, when we bury the electrode in the soil, the current is scattering actually. The current is not at all constant at all. The potential is falling, the current is scattering. That is why it is mentioned the dotted line here actually. Here this is the electrode we are supposed to connect in the soil. We are supposed to connect, we are supposed to bury in the soil, and the current is scattering, the voltage is falling here. If we have voltage and current means actually this terminal we will be having voltage, this terminal we will be having current. Then if we have voltage and current means we are able to measure the earth resistance. This is the principle we are using in the measurement of earth resistance. Okay, and we have to keep the earth resistance actually. Suppose if we are connecting this potential electrode from the earth pit at a distance of 5 meter means another current electrode should be connected at a distance of 10 meter from the earth pit. Okay, this is how equal distance we should connect current electrode, potential electrode as well as current electrode from the earth pit. Okay, P2 is from 5 meter distance of that is earth pit means E2 should be connected connected the same 5 meter from P2. Okay, this should be this. Now let me tell you this actually. This is example. This is here. And this is 5 meter means actually this also should be 5 meter. Okay, and the same distance, suppose if it is 2 meter means the same 2 meter should be used here. Okay, the same distance, we have to vary the distance and we have to see the by this is the test button will be there. By keep pressing this test button, it will show you how much amount of earth resistance. Okay, this is how we are able to measure the earth resistance. We will demonstrate you right now. Okay, here this is the table we are going to tabulate while we take readings. Distance between the electrodes and earth resistance measured. We are supposed to measure the distance in terms of feet actually. That is 2 feet. Actually, how much amount of earth resistance is 7.24. 4 feet 5.69. 6 feet 3.26. Okay, once you take all these values, then you have to add all these things and divide by 3. Then if it will give you the average value. Actually, this is how we are able to measure the earth resistance. Why we are going for earth resistance means actually in order to avoid shock, we are going for measuring the earth resistance, because if you are having laptop or if you are having any other wet grinder or mixie juicer in your home means actually if you touch means sometimes you might have feel shock. In order to avoid shock, we should provide proper earthing. Unless we provide the proper earthing, the leakage current will be flowing through the device. Okay, the device will sometimes it will be damaged, and also you will get shock many times. Okay, in order to avoid those things, we should make a proper earthing. Okay, that's why the earthing is very important. The earthing is measurement of earth resistance has a lot of applications in power based industries, telecommunication. Okay, even if you go to petrol bunk, actually you might have seen actually in the earth resistance. Hereafter, if you visit any petrol bunk, and the earth resistance measurement is there actually. Okay, there is also the earth resistance application is played a major role. Okay, if you hereafter if you go to petrol bunk, you can see the earth resistance actually where it is. You can ask them, ask with the dealer of the petrol bunk, they will tell you where it is. Okay, you can see there also. These are all the applications of earth resistance measurement. Okay, this is the earth resistance tester kit. Actually, here what we have done is actually we have connected actually potential electrode to the with the help of green wire, and current electrode with the help of black and blue. This is the blue wire, actually black and blue wire we have connected. What we have done is actually the potential electrode green, and this is connected at a distance of 1 meter from the earth pit, and current electrode it is connected from potential electrode at a distance of 1 meter. By keep pressing this button, it will show you the earth resistance actually. Okay, here if you keep pressing this button, it will show you earth resistance. Here I think 11.35. Finally it showed 11.35. Okay, in the value will be shown, you have to take into account. This is how we have to. Once again I keep pressing, then it will show you. Yeah, 13.66 is the final resistance value. This is how we have to measure the earth resistance. 60 running, sir.
Yes, sir.
Two feet. Okay, here what we have connected is we have changed the distance. Earlier what we connected is actually what we connected at a distance of 1 feet. Now we are connected the electrodes at 2 feet each. The current electrode and potential electrode are kept at a distance of 2 feet. By keep pressing this button, test button, it will show you the earth resistance value. Now we can get the value of 16.41. Okay, this is the by keep pressing this button, it will show you the earth resistance. It is showing I think keep pressing this button, 17. 17.39 is the earth resistance value. Okay, we have changed earlier we have taken the reading at a feet of 1. Now we have taken the earth resistance measurement at a distance of 2 feet. Okay, now we are changing the distance and we have to take the earth resistance once again. We have okay. Okay. Now we have changed the distance between the electrodes. The current electrode we have connected at E2 and the potential electrode we have connected here. We have changed the distance at feet 3. Now by keep pressing this button, what we are able to measure is the earth resistance value is around 14.18. Okay. Now once again I press this. Now it is showing exactly 13.44. okay, that is a value. By keep pressing this button, it will be varying. One point it will be suddenly stopped, and then that value you have to taken into account. 13.41 I think. Once again let me do that again. Keep changing. 13.46 is the final value. Okay, now we have connected the electrodes at 4 feet actually. Here by keep pressing this test button, what value does it show? Means let us see the value. The value is around 9.03. okay, 9.03 is the final value. 9.03. We have to measure earth resistance at a feet of 1, 2, 3 and 4. We have measured the values and the corresponding resistance we have taken with the help of earth resistance tester. Okay, thank you all. We have taken earth resistance 1 feet, 2 feet, 3 feet and 4 feet. We have to take the average of 4 readings actually. 3, 4, 5, 6 means we have to add all these things and we have to divide by 4. Then it will give you the average value of earth resistance. Okay, and also this is how we are able to measure the earth resistance. Okay, that's all.